Welcome. Today we're diving into a technological shift that honestly sounds like it's straight out of science fiction, but it's not. It's happening on tarmacs and in factories right now. We're talking about how augmented and virtual reality are completely changing aviation, from the way planes are built to the way you and I fly in them. So, let's just start with a number that shows you the sheer scale of this thing. By 2032, the market for AR and VR in aviation, it's projected to hit over $20 billion. I mean, we're talking a growth rate of nearly 38% a year. That tells you one thing. The entire industry is betting big on this technology.
So what does that massive investment actually look like on the ground? Well, take a look at this. Boeing was looking at a super complex task, wire harness assembly. Using old-school paper manuals, their technicians had about a 50% first-time accuracy rate. Not bad. But then, you give them AR smart glasses that project the instructions right into their field of view, and that accuracy jumps to an incredible 90%. That's a massive leap.
All right, so let's start our journey right where the planes are born, in design and manufacturing. This is all about building them better, faster, and with way fewer errors than ever before. For a company like Boeing, that kind of jump in accuracy creates this huge domino effect. By using AR in different parts of their production line, they've managed to slash the total time it takes to build a plane by 40%. In such a competitive market, getting planes built and delivered that much faster is a total game changer.
And it's not just on the assembly line either. Look at what's happening in the design phase. Before a single piece of metal is ever cut, engineers at Airbus can literally put on a mixed reality headset and walk around a full-scale 3D model of a new design. This process cut their design validation time by a whopping 80%. That means new ideas get off the drawing board and into the sky way faster.
Okay, so we've built the plane. Now let's talk about the people who fly and work on it. Because in aviation, the best way to handle an emergency is to have already practiced it 100 times in a safe environment.
This chart right here, this is one of the most powerful examples of VR in action. A major airline found that their cabin crew, when trained the traditional way, were making mistakes on about a quarter of their live evaluations. But, get this, after just 20 minutes of practice in a VR simulation, that error rate plummets to just 2%. I mean, just think about what that means for passenger safety. And for pilots, this is a huge deal. The training is just as effective as those multi-million-dollar full-motion simulators, but it costs a fraction of the price. Now, this isn't just about saving money. It's about making top-tier training accessible to way more people, which is absolutely critical when you think about the global pilot shortage we're facing. All right, the planes are built, the crews are trained. Now we have to keep them flying safely. And in the high-stakes world of aircraft maintenance, this is where AR is completely transforming the whole process. Let's picture the old way of doing things. A full top-to-bottom inspection of an aircraft. This was a massive undertaking. We're talking teams of technicians, scaffolding, tons of paperwork. It could take up to 2 full working days, keeping that very valuable plane on the ground.
Now, look at the after picture. It's just astonishing. Instead of teams climbing all over scaffolding, you have automated drones scanning the entire plane. AR software analyzes all that footage and flags any potential issues for a technician to check out. That whole 2-day process, it now takes about 2 hours. The plane is back in service faster, and honestly, it's a lot safer for the maintenance crew too.
So what does this actually look like for the technician with their wrench in their hand? Well, they pop on a pair of smart glasses, and boom! Suddenly they're seeing digital instructions, torque specs, diagrams, all overlaid right onto the engine they're working on. Both of their hands are completely free to use their tools. And here's the best part. If they hit a snag, they can start a video call and show a senior expert anywhere in the world exactly what they're seeing and get step-by-step guidance right then and there.
But this impact doesn't stop on the ground. This tech is now fundamentally changing the experience of actually being in the air, both for the people flying the plane and for all of us sitting in the back.
First, a super quick definition for a key piece of tech that's making this possible. The heads-up display, or HUD. Just think of it as a transparent screen that puts critical information right in your line of sight, so you don't have to keep looking down at your instruments.
And this is where that HUD becomes an absolute game changer. AR systems literally project all the critical flight data, your speed, altitude, heading, right onto the pilot's view of the outside world. In bad weather, it can even outline the runway or show nearby terrain that would otherwise be totally invisible. This is a massive boost to situational awareness, especially during takeoff and landing, which are the two most demanding parts of any flight.
And what about us, the passengers? Well, this could mean a future of in-flight entertainment you just can't get anywhere else. Imagine looking out your window and seeing an AR overlay highlighting the cities and landmarks passing below. Or maybe you pop on a VR headset to take a virtual tour of your destination, all from 30,000 feet.
Of course, it's not all smooth sailing. Like any huge technological leap, the path to getting this everywhere, well, it isn't without some challenges. There's a bit of turbulence to navigate before this becomes standard on every single flight.
So what's holding it back? Well, first up, the cost. Aviation-grade hardware is really expensive. Second, you've got regulations. Any new tech has to go through tons of rigorous testing and get certified. And finally, there's still some technical kinks to iron out, from making sure VR doesn't cause motion sickness to getting these brand new systems to talk to the existing tech on a 30-year-old plane.
But the really exciting part is what comes next. It's not just about AR and VR by themselves, but how they connect with other powerful tech. You've probably heard the term digital twin. Well, imagine a perfect virtual copy of a real plane that's in the air right now, being fed live data from its physical counterpart. Technicians could use VR to test a complex repair on the digital twin before ever touching the real aircraft.
So where does all this leave us? We've seen how this technology is basically rebuilding the aircraft from the inside out, right? The plane itself is becoming a smarter, safer, more efficient machine. So that just leaves us with one big question. As the aircraft is completely transformed, how will it ultimately transform us, the passenger?